Okay, so anti-differentiation is the opposite of taking a derivative. It's integration, but the one reason why we call it anti-differentiation in this case is typically because we're not solving for a specific value. So that's where that plus c at the end of this rule is. So the way this rule reads is if you integrate some term x raised to a power n in respect to x, it yields the result x to the n plus 1 power divided by the quantity of n plus 1 plus some constant c. Now, that's a really big, fancy way of saying you add 1 to the power and divide by that new power. So if we were to look at the following example, let's say I'm given the equation. They want me to integrate 3x squared plus 7x minus 1 over x cubed. Okay, I can rewrite this as 3x squared plus 7x minus x to the negative third power. Now, what I end up getting here when I integrate this, let's just look at this first term broken down, and then I'll just proceed like normal. If I were to break down this term, if I need to add 1 to the power, that becomes x cubed. So I have 3x cubed, but then I need to divide by my new power. So I divide by 3, and I end up just getting x cubed. The next one, I add 1 to the power, I get x squared, and divide by that power. So I have 7/2 x squared. And then the last one is where it gets a little bit trickier, but I'm going to add 1. So I have x to the negative 2 power and divide by that negative 2. But I already have a negative 1, so a negative divided by a negative becomes a positive. Okay, so this is my term plus c, some constant c. And I'll explain where that c comes from in a moment. It's basically just because of the fact that the function isn't defined with values. They would have to give us a point in this equation to figure out what c is. So let's check it. And the way we check it is to undo our work. So what I would like you to do is just take the derivative of this equation. Remember, when you take the derivative, you pull down the power. So we have 3x squared plus 7x minus x to the negative third power. And then in a derivative, whatever that constant, because it doesn't have an x term, even if it was 5,000 or just 5, it goes away when we take the derivative. So that is the equation that I had right here. So I know I did it right. I checked my work. Okay, moving on from there. Sorry. Moving on from there, maybe if I can erase my work. There we go. Here are a couple of extra ones for you to remember. Again, it's just the opposite of the derivatives. So if you know your derivatives, you should know your integrals. But these are the ones that are on your formula sheet. Just keep them in mind. Your calculator can actually do an integral for you typically. All you have to do is press your math button and scroll down to the integrate button. It's right under the derivative button. I don't want you to necessarily become too dependent on that, because remember, one portion of your test is going to be without a calculator. So you need to reinforce this skill without that calculator, but it's a good way to check your work as well. Okay, so now let me see if I can explain where this plus c concept comes from. It goes back to that idea that I was just talking about where we said that C value could be 5 or 500. It doesn't matter. When you take the derivative, that value goes away. So because we don't know what that C value is, we leave it undefined. However, on your Delta Math, I have given you an example of where you would need to solve for C. And this is how you would solve for C. So I'm going to go through this example problem. And then the next one is very similar on your Delta Math. It just has trig equations. Okay, so the first thing is I have a velocity equation and I want to talk about position. Now, position would be the level above velocity, which means I need to integrate. So I need to integrate the function 6t squared minus 1 in respect to t. And what I end up getting when I take that integral is 2t cubed minus t plus c. So I've been given this equation for x of t, and they give me a point. They tell me when t is 1 that it equals 7. So I can plug it in. And that allows me to solve for c, my c value. So I have 7 is equal to 2 minus 1 plus c, which 6 is equal to c. So now that I have my c value, I can plug it back into this equation. And then they want to find the position when t equals 3. So I would just plug it in. So x of 3 is equal to 2 times 3 cubed minus 3 plus 6, which is equal to 27 times 2, 54, minus 3, 51, plus 6, 57. I think I did that all in my head, sorry. So I don't think it really adds that much to plug in the values to solve for C in this case. So I did go ahead and add it to your Delta Math. The next example is the exact same premise, except it has trig. So same thing, except you're plugging in these values. Make sure you're in radians in your calculator, but that should do it.